Hey, we're back! This is Luis Rodriguez from Digital Cooks, and it's been a while. I know it's been almost a year and a half, I think, but what is this video about? We're going to be looking at the reasons why we decided to build Piña 4, and we're going to be comparing it to Piña 3 just to see what are the main differences and the reasons why we decided to choose that design route. We have an early prototype of Piña 4 that will help us to kind of visualize the differences and the main complications that actually we had during the design. Here we're gonna start the comparison with Piña 3, going over some of the main features that it had back in the days, already like 2-3 years ago, to understand the jump from this one to Piña 4. Piña 3 has one major component, that is dimension. It's reduced to fit under the cabinets of the kitchen. The main build plate is made out of stainless steel, and obviously because it's a Delta printer, the food that is printed stays steady and only the extruder the extruder moves along. And it uses two magnetic ball joints, what makes it really easy to disassemble, and I think is one of the biggest safety built-in features that help us during travels to keep the printer alive. And it's powered by a SMODI board. I've been really happy with this printer. I've been using it for the last 3 years almost. Really happy on how reliable it is and how has performed until now. So we've been talking about the main characteristics of Piña 3. Now let's take a look at the first iteration of Piña 4. So to start, and the main reason why I'm building this iteration is because I wanted to have a printer where the base or the build plate is printing on air. And what I mean by air is that there is no metal around in any kind of human interaction with the machine. And for me, that is important because it kind of creates a more clean environment where things can happen. Now I have all this open space to put whatever I want. Like for example, I can put a door right underneath and start experimenting on how cold temperatures affect whatever I'm printing on top with a small build plate, or put a pot with boiling water and print directly on it. Future ideas, the main key aspect for this type of design iteration was to use a rotary delta type of robot control to actually have this clean build plate without the columns. I can show you a small moving demo of how the printer will work in the future. So as you can see, just as you can see, the biceps move up and down, and the motion is transmitted through the arms. These arms also are different from the previous one. They don't use magnetic ball joints, and the reason is because I wasn't sure if that was going to be strong enough, and I changed to a socket, a springy type of solution for the retention of the end effector. Took a few iterations, but so far it's working. I forgot to mention, the printer is running on Duet 3D board. And the reason for the change, it was to have rotary delta kinematics embedded, and the documentation is great. I hope you enjoyed the video. It's been a while since the last video we made, so I hope you enjoy. I hope you forgive us from the hiccups and the getting up and running again with the whole shooting videos, but I hope you enjoy. If you have any questions, don't hesitate to contact us. Probably the easiest way is through Instagram. And just to finish, also I want to say thank you to our first Patreon supporter. This video would have never happened without you, and totally you gave us the confidence to, keep doing things, sharing what we do, because that's what we love and what we think is the right way to keep moving forward on 3D food printing. Well, until the next video, thank you. Digital Cooks.